Section 1.5, example 30, using substitution to find the antiderivative. So use substitution to find the antiderivative of this function. Let's start with the definition. So with the definition, we have the integral of a function f of, we'll say g of x, times g prime of x dx. So we're looking at a function within a function. So in this case, our inside function is going to be this one here. Our outside function is going to be this out here. What we have here, let me finish the definition. This is equal to the integral of f of u of x dx, or actually just f of u du. So a general term like that, which this ends up being f of u, so some u function with the constant. And since we were always in terms of x, let's flip it back in and say that f of g of x plus c is our actual function that we have. So again, what we have is like a composite function, one function inside of another. We take the derivative of that. As long as we have the derivative outside of that, we're able to integrate that. So we're able to do a substitution, something that we could integrate f of u du. Now that this is a function that's easily integrable, we end up with this function here. So our new function, our integrated function, but this one's in terms of u. What we want it to be is in terms of x. So we substitute that part back in. I know it seems a little weird, so let's get this example out of the way just so you could see it a little bit easier. So the integral of 6x, 3x squared plus 4 to the power 4 dx. So if we wanted to, we could completely expand this part. We could do it with Pascal's triangle, but I think it'd be a little bit easier to just find something here. So if we look at this inside part, we have 3 to the power x plus 4, or 3x to the power 2 plus 4. When we integrate this, so prime, we end up with 6x. And actually we don't end up with anything, but more importantly, we have a 6x just hanging out here. So it's really easy to do that part. So what we're going to do is let u equal 3x squared plus 4. Let's differentiate this. So du is equal to 6x dx. And now I see that part. So wherever we see a 6x dx, which we actually have that here, we're going to replace it with du. So let me rewrite this so that way we could actually find that part. So 3x squared plus 4 to the power 4. And I'm just going to move this one over closer to that dx. So we could substitute it. 6x dx. So now, wherever we see a 3x squared plus 4, we're going to substitute u. So for this whole thing here, so this is going to be u to the power 4. And also, wherever we see a 6x dx, we're going to substitute a du. So this is no longer that, it's du. So let's do our substitutions. So here we said that let u equal 3x squared plus 4. So u to the power 4. We also said let du equal 6x dx, which is this one here. So we're going to put du. Now let's hide the rest of it. This is something that we could integrate really, really easily. So to integrate that part, we would just say u to the power 5. We're multiplying that by 1 over 5 plus some constant that we don't really know exactly what it is, but we know that that constant's still there. All right, so we just integrated that, but we should be in terms of x's. So the integral was in terms of x's, and we are in terms of u's right now. So instead of u, let's replace it with that 3x squared plus 4. 1/5, 3x squared plus 4 to the power 5 plus c. And that's it. That is our definite or indefinite integral. And if you have any questions, please feel free to ask. Otherwise, bye.